First thing about a great conference like this, this is great with it being, so much more open, and the key being systems we love. A lot of us have used languages, operating systems, whatever in the past where we've used them because we had to. But the BeOS was a system that I really enjoyed using and really relished the opportunity to take this time to share what I know about it with others. Has anyone else here really heard about the BeOS? Okay, a handful. Anyone who's run it on their systems? Anyone who's owned a B-box? All right, one. Wow, that's more than I expected. I thought I'd be alone there. So anyway, back in the late 80s, early 90s, there was a lot of changes going on in the operating system world. We had DOS going to Windows and eventually leading to Windows 95. On the Macintosh, you started with the macOS system 5, 6, eventually becoming System 7, which a lot of people really got used to. And then also you had other projects that were attempting to build new operating systems, but never quite got off to where they wanted to, never became the big commercial success they had hoped for. For example, you had Microsoft and IBM joining together to build OS/2, where after a while Microsoft has said, well, this isn't really our thing, and went their own separate way with what became Windows NT. Then you had IBM and Apple coming together to form Taligent, another big development project which ended up becoming a constant cycle of moving goalposts and not quite reaching what they ever hoped for. During all of this, a few folks left Apple and ended up founding their own company called B. Their idea was to start off from a clean slate, start taking advantage of the type of hardware that was starting to become available, build a light modular system with object-oriented APIs and multi-threading everywhere, and even building it on their own hardware, where they built the B box. It was based on a dual PowerPC configuration, which was, one of the neat things about the PowerPC 603 is it was really designed, and for most systems, most Macintoshes that had the 603, it was a single processor system. But the system controller that the chip interfaced with was designed to interface the CPU, your level 2 cache, your RAM, and your PCI bus. But it had a feature where if you decided, we can go without level 2 cache, and instead we'll synchronize to a second CPU. So they were building their own hardware with a multi-processor, low-cost system. The idea of using the two processors rather than constantly expecting CPUs to get bigger and faster in the future. And obviously the really eye-catching part of it was the blinking lights on the front, which was a bunch of LEDs behind the front panel showing you the CPU load on each of the two CPUs. And as if that wasn't, eye-catching enough, then you had what you get around on the backside of the box, where I think they started a committee for what ports do we want to put on this machine, and just didn't know where to stop. Because you got to have the obvious ones. You got your keyboard and your mouse port, SCSI for external disks, because eventually you're going to fill up the machine inside, parallel port for a printer, then a serial port, maybe 2, no, let's go 4 serial ports. We want some audio, so we'll put both line level and microphone, or headphone and microphone jacks on it. 2 analog joystick ports. Since you've got this audio designed to hook it up to your headphones or your stereo system, well, we'll put a couple ports on there. You can wire up a couple of LEDs and use it to control your TV, your sound system, whatever, right from the system. 2 pairs of MIDI ports. And then this, called the Geek port, which is a 37-pin connector, which has 16 digital I/O lines, 4 analog to digital, 4 digital to analog, plus a bunch of 5-volt plus and minus 12-volt lines for it. So if you wanted to wire something up, you're going to find some way to be able to hook it up to this system. Of course, with everything on the, all that on the hardware, the software itself had its own fun aspects to it you'd come across when reading through the documentation. This function here from the kernel kit to determine is the computer on, returns 1 if the computer is on. Self-explanatory. But But sometimes, you may want even more information than that. So not only can you find out, is the computer on fire? Returns the temperature. If the motherboard is currently on fire, smoldering does not count. So they built the B box for several years, from 95 to 97. And during all of this time while they were building it, it's kind of hard to break into the hardware, manufacturing a brand new computer and getting it to market, unless you have the huge resources for the types of actual physical manufacturing process. But during this window of time when they were making this was when Apple was going through the process of opening up the Macintosh hardware for other third-party companies to build Macintosh clones. And so from that, they were able to port the BeOS so you could run it on your PowerPC Macintosh. Some of the clone manufacturers even included BeOS CD with their system, which was how I had my first introduction to using the BeOS during my normal daily use. However, at one point, when Apple's fortunes changed and they bought out Next and brought Steve Jobs back as the CEO, that was the end of the clone program. But B had already made plans. They had ported their system to the regular x86 architecture, so you could run it on your normal PC that most people are gonna have a little more frequently. They even put out a personal edition of the BeOS, which had a special trick that you could do back on the Windows 95 days, where you would have a large image file on the disk, on your regular fat formatted Windows disk. You would then start a launcher from inside Windows, which would then stomp on top of Windows, load BeOS, pointing to that big disk image as its disk, and it would boot without having to repartition or reformat your PC. They also built the BIA, which was a version of the operating system that was tuned for the early internet appliance market, when all the rage and everyone was predicting that in another couple of years you'd have refrigerators with big touch screens embedded in them, similar to other embedded systems like the Chrome OS now, where you boot it up and it just loads a web browser. However, B's fortunes didn't turn out like they had expected. They never quite got the market adoption that they had hoped for. After the change in Apple, they weren't able to continue porting to new PowerPC Macintoshes, because Apple was keeping all of that information close to the vest and no longer sharing it. They also had problems getting into the PC market because of the lock that Microsoft had on the desktop. At one point, B was even offering to give BeOS for free for any larger PC manufacturer that wanted it. And they had, I believe there was one company in Japan that actually did bundle BeOS as an option on the hard disk. And unfortunately, in 2001, they ended up closing down the company. The assets got sold off to Palm. And in other circumstances, that could have been the end of the BeOS. However, like any operating system that gains a fanatical following, people carried on, and the Haiku project was started. Because BeOS was so modular, they started off by rewriting the various portions of the BeOS and gradually replacing them one at a time with the newly written Haiku modules. It started in 2001. And by 2008, they'd gotten to the point where they were now completely self-hosted, where they could run Haiku, compile the Haiku code, and then boot that code with no longer needing any of the previous BeOS modules that they'd been relying on for the past 8 years. And since that time, they've even gone on to expand the system by improving the network stack, adding Wi-Fi support, actually adding a packaging system with an online repository now, so you're no longer having to download a zip file. Also, one thing that the BeOS did not have, which was a dynamic window layout. In the BeOS, if you were programming applications, you had to specifically say, this widget's going to be so many pixels by so many pixels, and this other widget's going to be, 20 pixels to the right of it. They also have experimental builds if you want to run Haiku without having to have compatibility for the old BeOS applications. There's even an experimental ARM and 64-bit x86 versions available. So this is really a file system talk, because we'll get into the bits of what BeOS did that I really enjoyed. So all file systems, you're going to have some form of metadata with all your files. Whether it's a timestamp information, permissions on that file, all these things that the file system needs to know, needs to interpret for you to be able to access the useful data you have inside of those files. A lot of file systems now support extended attributes. And those are things that aren't necessarily interpreted by the file system itself, but have additional meaning for the applications or for you, the user. In this instance, this was a screenshot I took off of a Mac OS system where I have a file, and using the x8r command, I'm showing an attribute that the browser has attached onto this file, where it gives you not only the web page that the file was downloaded from, but the original URL where it was found online. Now with these extended attributes, a lot of times you need to have the application support to understand how to interact with them. If you don't have an application or a program that knows how to work with those attributes, you could end up losing information. If you're copying something from one file system to, a fat formatted USB stick, if it doesn't know how to encode those attributes over correctly, you might end up dropping information. You also have to deal with different APIs. In some ways, a lot of these APIs are very similar. In here, the Linux and AIX, even though the function calls are different, they use the same argument list. The Mac OS uses the same function call as Linux, however, the argument list it takes is slightly different. BSD has their own set of system calls, and then on the Solaris and Illumos side, it uses something completely different altogether. But what the B file system did is that it really counted those attributes as being a first-class part of the file system. The file system on BeOS was built to take advantage of the multi-threaded nature of the operating system and still produce a lot of features in a relatively low memory footprint for the machines at the time. The primary work was done by Dominic and Cyril, who are two engineers at B. Cyril built the VFS layer because that was a portion that previously the BeOS didn't have. And then Dominic was the one who did most of the work of the actual parts of what's going to be, how it's going to wind up on the actual blocks on disk. Since B, Dominic has moved on. He is now at Apple. He's been there for quite some time, where he was responsible in the years for adding journaling to HFS+, the Spotlight, Time Machine, and is now also a part of their team building the new APFS, which is going to eventually replace the old HFS code in macOS. BFS also had features that other file systems weren't presenting at the day, with 64-bit file support and also journaling for quick error recovery after a crash. And it used the same object-oriented API like the rest of the operating system, but you still had a POSIX compatible interface for any other programs that you wanted to build, whether it was standard C, open source things you would get online. Now with the extended attributes in the BeOS, you had the node object, which is your main interface into the storage, and all of the different types of file system objects inside the storage would be just descendants of the node object, whether it's a directory, an actual file, or a symlink. But when you're querying these APIs, you can see here on the right-hand side is a list of some attributes that are associated with, in this case, it's the web browser that comes with the BeOS, or I'm sorry, with the Haiku. Where it has a MIME type, it has a string of text that identifies the package and file information associated with this installation. And then there's also some 4-letter character signatures that identify special attributes that other things care about. In this case, it's identifying the information for the icons and application information that the tracker, which is sort of the user interface, the Windows Explorer, the Finder equivalent for Haiku. You also have command line tools you can use to query the same information. You can create new attributes, remove ones that a file no longer needs. Really, building this stuff into the system all the way from top to bottom. In this case, this is a screenshot of the people application. Instead of having a standard contact list or address book manager, you had the application here that updated information for a contact, and all the fields were simply additional attributes that were associated with the file, which you could manipulate with any other utility programs. When an application is installed on the system, it identifies to the system the MIME type of the files that it will work with, along with the types of attributes that it can be expected to manipulate. And so in here, this is the file types system preference panel. In here you have the application X person is the MIME type associated with someone's contact information. And you have the list of the extra attributes associated with it there, the standard things like email address, state, zip code. And so you can edit those. Here you see for email, the actual on-disk attribute name is meta email. You can specify the type it is, how much size it takes in the file viewer when you're looking at it. You can even add new things. In this case here, I've added a Twitter field with their Twitter account handle. And now, the next time you open up the People app, Twitter is now just a new field that it appears. And in fact, you can even now modify these using the standard tools. The People application, when it starts up, it is associated a query keeping track of the attributes on this file. So as soon as you run the command in the terminal that updates an attribute with the file, the People app gets a notification and it will read the attribute and display the update right away. Now all of this on its own is really useful, but what really brings it all together is the indexes that you can specify for the file system. The old versions of the BFS file system from the very early days of B, before they became public, before they were manufacturing the B box, did these indexes, but the indexing process was run in user space, and so you'd have situations where a lot of updates to the file system, the indexing process would lag behind the state of what's ending up on disk. And also if you have a crash, now you've got an inconsistent state and you're going to have to either toss out your indexes and rebuild everything or do some other error recovery process that's going to be long and painful and not what you want to do when you're waiting for your desktop to come back up and get back to work. So when they wrote the version of the BFS in 97, they made these indexes a part of the file system code, built right in using a tree, B+ tree, which has a larger number of nodes, so you're not having to go down as deep into the tree to find what you're looking for. You're also able to then spread the work out across processors. And you can build these indexes on specific types of attributes. You can't just build it on any random attribute. But they just focused on integers, longs, text strings, floats, and doubles. And then also in the file system itself, it keeps track of your inode data for the name, size of the file, and last modified time. So an application can tell the file system what attributes it wants the file system to keep an index of. And then anytime an update occurs, whether it's an update to an inode information or a change to an attribute, that update automatically goes through to change in the database itself. If you create an attribute on the file system after the fact, when you already have, say you're adding an attribute onto your audio files, and you already have a bunch of audio files existing, well then there's a reindex command you can run to walk through your file system, find any missing attributes, and update those into the database. And then all apps can use the same interface for querying into this system. Now you can do either a single one-off request to request a bunch of information and then get back the list of the matching files. Or when you're using the full object-oriented interface, you can do a live query where you pass the list of attributes you're searching for into the system, and then the kernel will pass messages back to your app whenever there's any update that's updating in the database for an attribute that you're actively watching at the time. As an example of this, here you have this is the find window in Haiku. The BeOS one was very similar. Here I'm looking for an audio file, which the audio applications have told the system audio files will have artist name, track title, track number, genre, and year as possible attributes for it. So I'm searching for a year which is between 1990 and 1995. And in fact, that then behind the scenes is actually this almost kind of a query string listing the different types of information, breakdown of the attributes that we're searching for. And it's got this great line from the user guide for Haiku that says, all you need is a basic understanding of regular expressions and maybe some scripting basics. And so when you query something from the command line, using the exact same query string that the find system uses, this is what you see come back. It's just the list of file paths with every file matching, in this case, between the 2 years of 90 and 95. In this case, I added the specifier of genre soundtrack and a MIME type of audio star. You can then save these queries. They save just as another file on disk, which again has its own MIME type associated with it, saves the string of what you're searching for, and so you can relaunch these at a later time, or even just have a window open. The Mail app on BeOS didn't have its own directory listing or list of all your messages in a mailbox. You simply had a tracker window open. And if you're looking for new mail, you have a query window open that says, I'm looking for messages that have a status equals new, and a mail header from any particular person that you're looking for new mail from, and that window will just update and pop up the new messages as they arrive on disk. There are some downsides to the indexing system. You can have a lot of indexes. This was the listing from my Haiku system that I was testing on. Just going through and just having indexes on audio files, email, and the people contact database, and you ended up with almost 50 different indexes created. So sometimes it can be difficult keeping track of what is tracking what on the system. And if you're doing a lot of I/O, especially if you're doing something that has to do a lot of regular expressions, you can end up doing quite a lot of I/O digging through that database trying to find it. Because of the tree structure of the database, a regular expression, we're searching for a pattern. Specifically, even the worst case is when you're looking for a pattern at the beginning of a string, that's going to basically end up having to walk the entire tree trying to find a file name that you're looking for. Also with the BeOS, one of the downsides of it is that it really did not have the multi-user capabilities that most operating systems are going to have today. When you were on the BeOS, basically everything was running as the root user. There really wasn't any separate permissions or privileges. Everything that was on the file system was on the file system indexed for you to find. Now, I do have ulterior motives from this talk. It's self-promotion for myself, getting out here and doing something, like we said, with the systems we love. This was a system I enjoyed loving. But most of all, I really do miss having this feature. When I was talking to a friend of mine, telling him that was just giving the details about what I was going to get into with this talk, he had some experience using BeOS in the past, and he as well said, yeah, he really missed having that kind of quick responsiveness and the real ease of being able to find your things. He complained quite a bit about how Spotlight is very difficult to find things if you're getting outside of a particularly limited selection of what you're searching for. And that there's other tools out there like Find and Locate, which do a lot now to help you find those files you're looking for, that PDF of a tax form for 8 years ago, the documentation you wrote up with a to-do list that you put somewhere but you don't quite remember where. But tools like Find is going to walk the entire disk. It's going to take a long time. And something like Locate will be faster, but it's going to be out of date with the file system depending on how much change you have occurring. And so I would really love to have something like these indexes in ZFS. I've been a long time Solaris and now a Lumos user, and ZFS from the file system side has really made things in managing file systems for me so much more of a joy to deal with. However, I don't understand the deep down internals part. And so this is where the systems we love. I've showed you the things that I love about BeOS and now Haiku as well, but I don't understand how this would come about and how this would apply on ZFS. There's a lot of things with ZFS. How do you deal with delegated admin privileges, where you can grant users permissions to do things like make a snapshot, make a clone of a file system? How does that apply in a situation of creating an index and querying that index if there's files on disk which aren't necessarily owned by the person looking for things? And so this is where I'm sharing this, so that hopefully there's someone here or someone's going to watch this video that this will put an idea in their heads, and some way we'll be able to improve the systems that we love, and that we'll be able to continue loving them even more in the future. Here for reference, I've got a couple links. The Haiku project, where people continue to improve and develop the Haiku operating system. You can try it out, throw it on a virtual machine. It really does not need a lot of memory. It's still very fast and responsive. The documentation, both the Haiku user guide and the B book, which is the documentation set that B published for the system back when they were still operational. A great article on Ars Technica that kind of goes into more about the B file system and some of the ways that it implemented things in the actual how things get to arrive on disk. And then finally, at the top there, I have a link to archive.org, because the B website has been long gone by now, but with more of the specifications of the B-Box hardware. And if anyone, like I said, if anyone enjoyed this and wants to see something like this in ZFS, maybe give me an email. We can talk sometimes, because I've got some ideas, and I hope this has inspired ideas with someone else out there too. Thank you.
Great, thank you very much.